Here we're asked to solve a linear system using matrices and Gaussian elimination. Let's begin by finding the corresponding augmented coefficient matrix. Now the goal is to find an equivalent matrix in upper triangular form. So we'll use the elementary row operations to try to replace this 4 with a 0. We can do that here by multiplying the first row by -4. Doing that, we'll be left with -4, 12, -8, and -64. And we'll write the second row right underneath that. Now adding these two rows together, we'll get 0, 1, -9, and 5. We'll use this to replace the second row. Next, we need to replace the first element here of the third row with a 0. To do that, we'll multiply the first row by -2. And that'll leave us with -2, 6, -4, and -32. Now we'll write the third row right underneath that, and then add them together. That'll give us 0, 1, -8, and 4. Now we'll use this to replace the third row. Now finally, we need to replace the second element of the third row here with a 0, and to do that, we can multiply the second row here by -1. Doing that, we get 0, -1, 9, and a -5. Rewriting the third row right underneath that, we can then add these together. That leaves us with 0, 0, 1, and -1. Now we'll use this to replace the third row again. And this leaves us with an equivalent matrix in upper triangular form. Now let's convert that back to a linear system and then solve by back substitution. And in this case, we know right away that z equals -1. Now we'll use that in the second equation to determine y. And so here we'll substitute z equals -1 and then solve. So we have y plus 9 equals 5, y equals then -4. And we'll use this and the fact that z equals -1 in the first equation to determine x. And so here we'll substitute -4 here in for y and -1 in for z. Solving, x plus 12 minus 2 then equals 16, or x plus 10 equals 16, x equals 6. Now once we have the values for x, y, and z, all that's left to do is to present our answer as an ordered triple. And we have 6, -4, -1. That's our solution.